One nugget, two major objectives. Number one, to talk about what routing protocols do, their function in your network. And number two, to look at a 10,000-foot view of the mainstream routing protocols in use today so that you can make a good decision of which one you want to use in your environment. Here are your do I know this already questions. So pause the video, read through these. If you know the answers, you probably can move on to the next video in this series. Otherwise, let's get started. I have a good friend who's a PHP software developer. We were having lunch just this last week, and he's always trying to suck me over to his side of the world. And he goes, dude, you could totally get PHP software programming. You just got to get if-then statements. It's really all there is to any programming language is if this, then that. It's that simple. And as I stood here staring at the screen, that conversation popped back into my head, and I go, you know, it's probably just about everything in technology is an if-then, a 0 or a 1, on, off, that kind of thing. And I'm looking at these routers that all start off very simple. They know nothing. And then you and I come on there and give it an IP address on the public and private network in this case. And now the router goes, oh, okay, I'm a little more intelligent. I know how to get to the 192.168.1 network. I know how to get to the 68.110.171 network because somebody gave me an IP address in there. But if somebody were to ask router 3, hey, how do I get to the 192.168.3.50 host? It would say, I don't know. That's an if statement that I don't have a then for. So you and I jump on router 3 and we say, okay, well, router 3, if you want to get to the 192.168.3 network, then go ahead and send the traffic down to 192.168.1.2 because he's the next hop on the way there. And then we go to that router and give him the next hop on the way there, and that's how we configure static routing, right? Just really a bunch of if-then statements that put it all together. Well, the whole glory of routing protocols, if we were to boil it down to its simplest essence, is to tell these routers, you know what? Rather than we, as network administrators, going on there and configuring them to point to each other and know where all these networks are, we say, hey, routers, why don't you just kind of do the work for us? Right? Well, you know what you've been configured with. You know what IP addresses you have. So why don't you just tell your friends what you know? That's the essence of routing protocols. So these routers all speak together and say, well, I know about this and I know about that. And well, if you know about this, then you must be my next hop. And they just kind of put the puzzle together until they have a roadmap of the network. Why is there an entire course on CBT Nuggets? Why is there a certification exam? That seems like the simple question. Well, it comes back to my software developer friend who's saying, oh, all there is if-then statements. I'm like, well, if it were that simple, everybody would be a PHP software programmer making a lot of money because it's that simple. The complexity comes in because we have all these different choices of routing protocols, each one which gives their own niche benefits that they fit into, and have their own drawbacks or caveats, considerations that you have to know about before you can just roll out a routing protocol that puts all these puzzle pieces together. So there are 6 mainstream routing protocols in the world today, 4 of which we're going to unpack in this series. So before we look at those 4, let me talk about the 2 we're not going to talk about, IGRP and ISIS. IGRP was just a bad idea from the beginning. Cisco designed it, Cisco proprietary, to compete with RIP. So let's start from that foundation, right? But it turned out that IGRP was actually slower than RIP when it all came to the full design. Less network traffic, but slower, so it's been gone. So I bite my tongue when I say 6 mainstream routing protocols, because that one's been gone for years and years. Don't even think about it, just gets an honorable mention. ISIS, on the other hand, what a firestorm of controversy around this protocol. It was designed for the OSI protocol. I know some people will say OSI model, right? No, OSI protocol, the one that was designed to compete with TCP/IP and lost. ISIS was the routing protocol for it, and it was so good, in fact, that people started saying, you know what, I prefer this over OSPF. And so they created integrated ISIS, which was a version of ISIS that worked for TCP/IP, but still relied on some heavy knowledge of OSI. Well, it's been removed from the Cisco route series for years and years and years. And just before I recorded this slide, I Googled OSPF versus ISIS, and the controversy is still out there. People are like, which do you prefer? And you know the internet, the internet is just full of angry people. You can't even get to a forum post that gives you any real meat. Like, it always starts like, I prefer ISIS because of, you get a bullet list, and then the next person's like, you know what, your mother's ugly. And then they're like, I don't like the tone of that. And so you have to weed through like 50 pages of forum posts of like why ISIS is not related to your mother being ugly or anything like that before you get any real meat Anyway, I'm on a soapbox, but nonetheless, I will say the major benefits of ISIS being easier on your router's processor, being less constrained in terms of design with the Area 0 backbone requirements and all that. A lot of those have been alleviated to the point where it's just a wash. So at the end of the day, people are like, you know what? I don't want to learn the OSI protocol. I don't want to muddy my knowledge of TCP/IP by having to lay this OSI foundation, which is still required for ISIS. So because of that, Cisco no longer covers it in the route series, and I would say for good reason. So what about the other four? Well, RIP is still around. Matter of fact, it made the jump to IPv6, and they now call it RIP Next Generation. But it's still the same old RIP, designed for a very small network. It's got its niche areas that it fits in, where maybe you've got a mainframe that only speaks RIP or something like that. It's around, but I would say very few people use it. In this series, I'm going to do one nugget on it and just do a demonstration of here it is in IPv4, here it is in IPv6. There we've seen it, let's move on, simply because it's on the exam requirements. Otherwise, honestly, I would just say, hey, don't even worry about it. The other three, those are the ones we want to spend time with. EIGRP will be the first major one we talk about in this series. EIGRP being a Cisco proprietary protocol, but because Cisco is so widespread and EIGRP is so good, it has caught on as what I would call a mainstream routing protocol. EIGRP combines the best benefits of distance vector with its easy to configure ways and kind of plug and play nature with the advanced features of a link state protocol, and that's where you end up with EIGRP. It can be tuned to be very fast to converge. So when you have a network failure, the hello messages of EIGRP can detect that and switch routes extremely fast, and then put all the pieces together. It just works well. It's designed to work well with Cisco. So I would say for a mid to large size network, EIGRP is golden. The reason I put it in that box of mid to large size networks is because once you grow outside of that, you usually start seeing other vendor equipment coming into the mix. And that becomes the major Achilles heel of EIGRP, is its proprietary nature. Unless you have extremely tight requirements on what equipment is allowed in your network, as the network grows, you're going to end up with a mix of vendors. And at that point, EIGRP just doesn't make sense because you start having to jump through hoops. Oh, well, let's use static routing on that device, or let's do some redistribution to make that device work. It's like, forget it. Let's just unify and go with the single OSPF. So with OSPF, the trade-off that you give is you get multi-vendor support. Essentially, OSPF is supported everywhere. And the trade-off is it's a less simple design. One example, OSPF uses an area design. So you have area 0 being the backbone where everything starts, and each area can contain 1 to 50 to 100 different routers. And essentially, the places that you are allowed to implement summarization is right on the area boundary. So for instance, I can say, okay, well, every network beginning with 10.1 is represented in area 0. So I'm going to summarize all these little routes, you know, all the /24s or /30s or whatever routes that you have inside of there, as I send that to area 1 and area 2, thus shrinking and making more efficient the routing table of those areas. That's the only place you can really summarize within an OSPF system, whereas EIGRP allows you to summarize anywhere. Just take a router, go under the interface, and say, that's where I want to do a summary route, and so you can quickly create boundaries and be more efficient easily with EIGRP. So that's just one of many different descriptions that I could give you on why OSPF and EIGRP are better or worse and all those kind of things. But at the end of the day, OSPF is the most popular routing protocol in the world for a reason. All of these protocols represent one major genre, internal. They're all designed to route your internal networks, private networks within your company. One stands apart, and that is BGP. It is our exterior routing protocol that takes the routing table of the internet and brings it into your devices. Now, most of the people that use BGP are going to be the service providers themselves because they have to find the most efficient route around the internet. However, BGP has come into the enterprise because The enterprise needs redundancy. It needs best practices. It needs to make sure that whatever servers they have are reachable from wherever they are in the world. It also runs into the place that the enterprise has stepped into the cloud themselves. A lot of enterprises are going into the data center. They're creating their own little private cloud presence. And so once they're in the data center, they can choose from a whole gamut of service providers, and they want to be redundant and all that kind of stuff. So enterprises have started to set up BGP as well. Now, BGP rarely stands on its own, meaning you won't just come to an organization and find out, oh, well, you're running BGP and that's it. There's no other protocols. There's always an underlying protocol to support it. Could be static routes, but it most likely is going to be OSPF, sometimes ISIS, sometimes EIGRP. Essentially, BGP runs on top of an internal routing protocol because it's designed for slowness. By design. When you handle a routing table the size of the internet, something has to give. You can't have that ninja fast convergence of, oh, it's down, quick, everybody react, go that direction, because BGP would explode because networks are going up and down all the time on the internet, right? So this is allowing you, with these internal routing protocols, which can be tuned for efficiency and all that kind of stuff, allows you to get that ninja fast routing at the foundation and then combine it with BGP. So if there's a failure in your network, you can quickly choose an alternate direction for internet access, either outgoing or incoming. Somebody else's network in the world still has to go through the process of BGP. And I have to bite my hand because literally I want to unpack every single one of those protocols in all their glory on a single jelly bean slide. But that's what the rest of this series is going to be about. So we're going to take those 4 routing protocols in order. RIP first gets its little own honorable mention nugget. Then we'll dive into EIGRP, OSPF, and finally BGP as we continue through this Cisco route series. I hope this has been informative for you, and I'd like to thank you for viewing.